Hi, this is Mrs. Weethy back for video lesson number 5 on physical changes, mixtures, and physical separation. So let's get started. Okay, a physical change is one that results in changing the appearance of a substance but leaving the composition unchanged. So, a change in the substance without changing its identity is a physical change. That's the key thing, not changing the identity of the substance. So, let's take a look at phase changes or changes of state. A lot of students get phase changes or changes of state confused and think that they're chemical changes. But these changes of state, when we say changes of state, like for melting, for instance, you're just going from a solid to a liquid, like we have the melting ice cube here. You have solid water in the ice cube, heat it up, it's going to go through a change of state into the liquid form. But no matter what, you have water. You have water in the solid state, you have water in the liquid form. It's still water. We have just changed the appearance. Opposite of melting, we have freezing, like we see here with the orange. And freezing goes now from the liquid to the solid. Another phase change is evaporation. And in evaporation, we have a liquid going to a gas. And opposite of evaporation is condensation, in which a gas now is going to cool down and change into a liquid. But no matter what, the substance is the same. It's just going from a gaseous state to a liquid state. Now, change of state I think is very interesting is sublimation, as we see here in the blue bowl. And this is where you have a solid is directly going to go into the gaseous state. So you're skipping that liquid phase. This is solid carbon dioxide. Solid carbon dioxide at room temperature is a solid, but it evaporates very quickly at room temperature. So it goes straight from that solid into the gaseous phase and gives us that illusion of fog. Opposite of sublimation, we have precipitation or deposition. Snow is an example of that, where you have water vapor in the atmosphere. When it comes down to Earth, it gets cold very fast because of the air temperature. So it goes from that gaseous state directly into the solid state in the form of either ice, hail, or the snowflakes. Now, another major classification of matter is mixtures. We said pure substances, elements, and compounds were examples of matter, a major classification. In a mixture, as we see here with the nuts and fruits, you have two or more substances that are physically combined, and if they're physically combined, they can be physically separated without changing the identity of the substance. There are two types of mixtures: a heterogeneous mixture, in which the substances are not smoothly blended throughout or do not have a uniform composition, where you can see the individual substances. They remain very distinct. Some examples are salad dressing, pizza, and a bowl of M&Ms. In fact, you are a heterogeneous mixture, as we can see all the components that make you up. This is a particle diagram of a mixture. So you see two different substances. You have these red spheres, and then you have what looks like a water molecule, but you can see they're separated from one another. They're not evenly distributed or evenly mixed within the mixture itself. A second type is a homogeneous mixture, also known as a solution. Key term here, solution. Anytime you see the word solution, that is indicative of a homogeneous mixture, which has two or more substances that have a constant composition or a uniform distribution of the components. So it looks like just a single phase. Looks like you only have one substance. Sugar water, salt water is an example. It just looks like a glass of water, but you have sugar dissolved in the water. How would you know? Well, you can evaporate the water and have the sugar left behind, or you can taste it and know that something's in the water. Now, of course, in the chemistry lab, you're not able to taste it, so you would have to evaporate it. Tea would be another example. It looks like one thing, but you have the tea, you have the water, and you might have some sugar in there, maybe some honey, but it just looks to you like you have one single phase. This is a particle diagram, and in the particle diagram we have the two substances, but now you can see they're evenly mixed together, and even though we can see the individual components, you have an even distribution of those components within the mixture. Now, we said that mixture is physically combined, so it can be physically separated. And we have 6 different types of physical separation. One is called distillation, and this is the separation of 2 or more liquids that have different boiling points. And so here's what happens. You have the 2 liquids mixed together. Looks like you have one. You heat them up. The first liquid, the one that has the lower boiling point, starts to boil. It evaporates. Once it completely evaporates, we can collect it. We can have it go through a tube called a condenser that would change it from a gas back into a liquid, and we can collect that separately from the other liquid, separating the 2 liquids in our mixture. Another means of separation is crystallization, in which you're forming a solid particles from the solution that it's dissolved in. Rock candy is an example of this. You have a supersaturated solution of sugar water. You start crystallizing that sugar around, let's say, a lollipop stick, and eventually all of that sugar is going to crystallize out of the water and separating it from the mixture itself. A third type is decanting, where you're simply pouring off a liquid from a solid. Let's say you have sand water. You let the sand water sit overnight, so all the sand settles to the bottom of your bucket, and you just pour off the water, so you're separating the sand from the water. That's nothing more than decanting. Chromatography is a technique in which you're separating components of a mixture, like inks, and they're going to travel along the surface of another material, which is called a stationary phase. So let's say that we have a piece of filter paper, and on this piece of filter paper we are going to put a mark of black ink. So we're going to put the black ink right here. And then what happens is we're going to take that chromatography paper, and we're going to put that chromatography paper into some water. And that water is going to travel up, or is going to be absorbed into onto the paper. And so as that water travels, up the paper, once it reaches this ink, that ink is going to dissolve in the water, and it's going to travel along the water. But what happens is the individual components of the ink is going to separate out. So let's say you have some blue ink is going to separate out here, and we have some red, and we have some yellow, and we have some green. And so we'll be able to separate out all the different colors that you have in that ink pigment. Larger particles, they're going to move slower, so they're going to separate out first. The smaller particles, they're going to be able to travel further along that chromatography paper and separate out last. So that is the basis of chromatography. We'll do a little lab activity involving the chromatography in class. Okay, a 5th type is called filtration, and you're probably familiar with filtration, in which you're using a piece of filter paper. You're going to pour a mixture, collect the solid on the filter paper, and the liquid is going to go through that porous barrier. And lastly, we have evaporation, where you're simply evaporating, heating up the liquid's going to evaporate, go into the gaseous phase, leaving the solid behind. And so it's the solid that we're going to collect. So those are 6 different means of physical separation of mixtures. This is the end of video lesson 5. This is Mrs. Wethy. So long for now.